This session is on the decomposition equation. I hope you would guess it's the opposite of composition, putting things together. Decomposition, like all equations, starts with the reactants. Reactant or reactants, either way. In decomposition, you have a single reactant. And the first thing we're going to do in the equation, we have to make sure we have a handle on the facts and deal with these facts. Facts are the fun part. They're the reality, the narrative, the description of what's happening. Remember, equations tell a story. Second thing we do is make sure all of our formulas are correct. Because if the formulas are correct, the equation has a chance to balance, which is number 3. Balance the atoms, and you do that by using the coefficients. All right, so let's start with an equation. Here's an equation that has major worldwide industrial importance. It starts with a substance called aluminum oxide, sometimes called the commercial name alumina. Okay. Now what we're going to do is decompose it, and this takes so much energy. I'll just jot down ELEC, meaning electricity, direct current. And we're going to get the metal, aluminum, plus oxygen gas. All right. There's also a substance here that you'll see many times called chlorate. It's a mineral. It's basically not used anymore as chlorate because it's been basically mined out. It came mainly from Greenland for years. It was mined out as much as 20 years ago. So now they use a man-made substance. It's sodium, aluminum, and fluorine together. I think sodium hexafluoroaluminate. How's that for a fancy title? But this substance is called a flux. It allows the aluminum oxide to be melded and separated very nicely into the aluminum and the oxygen. Okay, the second step is the correct formulas. Aluminum oxide is a metal plus a nonmetal. So we're going to list Al and oxygen. Now remember, it's not that shiny aluminum now. It's a white substance. Aluminum is a 3+ ion. Oxygen is 2- ion. This becomes Al2O3, a solid. And by the way, this substance comes from a very valuable ore called bauxite. It's nice to know that these things come from the real world. Australia is a big producer, some areas in South America and Africa. Aluminum oxide. You use electricity, and you get aluminum, Al. Oxygen is diatomic. Don't forget, one of the 7 diatomics. Second step, all the formulas are now correct. Third step is to balance it. Odd and evens, frequently you can attack from that approach. 3 and 2, common to 3 and 2 is 6. So you have 2 times 3 is 6. 3 times 2 is 6. 4 aluminum here, 4 aluminum here. It is balanced. This is a production. Aluminum metal, when it was first produced, was equal in value to things like silver and even gold. Now it's very, very cheap thanks to the Hall-Héroult process. Listen to that. I'm going to put their names down here. Charles Hall, 22 years old, from Oberlin College. Héroult, from France, about 22 years old also. Charles Hall became very wealthy, never married. In fact, a quick story on Hall is at one time he misspelled aluminum. He dropped the I up here, and it used to be IUM. It was called aluminium. So now in the United States, it's stuck. Aluminum is the United States. The rest of the world is still aluminium. But Hall never married and left his money to charities and a lot to Oberlin College. Okay, let's go to another equation. This is equation number 1. Equation number 2. This is an interesting one. If you take potassium chlorate and simply heat it. Now, you're going to see I'm going to put this delta sign. This is sometimes used in an equation, the change involving heat. This is test tube level heat with a Bunsen burner. And you get potassium chloride plus oxygen. Now, just the other day, I noticed on a website from some university, they had potassium chlorate. This is a polyatomic. This is a 1 plus and a 1 minus. It's called chlorate, polyatomic. And when it was heated, they wrote KCl plus O3. Now notice very quickly that's balanced. But the problem is this substance, O3, is called ozone, not the fact oxygen. So we have to erase O3 here. We'll get this right. We'll just spring it in here. And put it O2. There we are. O2. Oxygen. It's a gas. That's a solid. And that's a solid. To balance it, 3 and 2. 2 times 3 is 6 oxygen. 3 times 2 is 6 oxygen. 2 KCl. Okay, so there we have 2 decompositions. Sometimes the facts they will give you are limited to either the reactant side or the product side. In the first case, if they gave you the fact and they said decomposition of aluminum oxide, that's a fact, you could guess it would be aluminum and oxygen, the 2 elements. But potassium chlorate, you wouldn't quite know what would be there. So the facts have to be examined very carefully. Okay, these are the 2 equations we'll do in this session, and we will stop there right there, and we will go on to a very interesting type of equation called combustion. Combustion.